All right, guys, so last time we went over our lovely hydrocarbons. We learned how to make hydrocarbons, and today we are going to go over adding things to the hydrocarbons. So these are going to be called functional groups. This is when we add things to our hydrocarbon. Now, our hydrocarbon alone, it's just hydrogen and carbon together. This makes it nonpolar. In other words, this makes it so that it does not combine with water. It's like oil and water. The hydrocarbon alone is like the oil. It would separate from water. However, we can add these functional groups, and what these functional groups do is they can change the properties of that hydrocarbon, maybe make it polar. So if it is polar, it can combine with water, okay? But there's other things too. It could keep it nonpolar. It might make it acidic. It also could make it basic. So let me explain to you what this picture is down here. The R would represent, down here, the R would be the rest of our molecule. So the R right now would be our, hydrocarbon. That's our R. All right. So what we're going to do here, guys, for the first one is we are going to add this OH group. OH. So it's a hydrocarbon bonded to an O bonded to an H. That is called a hydroxyl group. And what that's going to do is it's going to make our hydrocarbon become polar instead of nonpolar. So what's nice about that is if we put it in water, it'll combine. So just adding that O and that H makes it combine with water. So that's our first functional group. Our next one is going to be called carboxyl. So what this one is it's a COOH group. So we are adding all of that to our hydrocarbon. What this one is going to do is it's going to make it an acid. So we're adding this, and our hydrocarbon would be right here. Okay, so there's your second one. It's a double bonded O, and then down here we have the hydroxyl group. But the whole thing as a whole is a little bit more than just the hydroxyl group as in the previous functional group. Next one is an amino group. Again, the R is our hydrocarbon. This is our amino group. It's a nitrogen bonded to two different hydrogens, and that's going to make it basic. So the last one we went over, carboxyl group, makes it acidic. This one makes it basic. What if we put both of them on a hydrocarbon? What's going to happen there? Well, it's probably going to stay pretty neutral. All right. If we put something basic with something acidic, it's probably going to still be basic or fairly neutral, or slightly basic or slightly acidic, but not a whole lot. And the last one, which we're going to use a lot throughout this year, is called the phosphate group. So it's PO4, as you can see there. I have it highlighted in like a green color. And then all this over here would be the rest of our, on the right side, the rest of our molecule, whatever it is. All right. Okay. So we're going to go over monomers, polymers, macromolecules, the relationship between all three. So the first thing is a monomer. Think of the monomer as one brick in the wall, one part of that wall, okay? What we're going to do is we are going to combine our monomers together. So take a monomer, combine it with another monomer, and when we do that, we have a polymer. Let me draw it out for you. So I'll make it real simple. We have a circle. That is a monomer. When we put two of these circles together, I will draw the bond in a different color so you guys can actually see they are bonded together. That's our bond. When we put two monomers together, we get a polymer. Okay. Just think of the prefixes, guys. Mono means one molecule. Polymer means many. So It's many monomers put together. Now, what we can do, guys, is we can keep adding our monomers to our polymer, add more and more and more and more. Once it gets gigantic, once it gets to be a huge polymer, and there's no real fixed number for this, but we are going to call it a macromolecule. It's a very, very, very big polymer. So, one is a monomer, more than one bonded together is a polymer, and then a bunch of them, whole big chain of them, that is a macromolecule. Here's another way to remember it, guys. Lovely Toy Story movie here. Yeah. Yay. They look like they're having so much fun. No. Okay, so if you guys have ever seen like the different toys in Toy Story, you know they have these little monkeys that you can kind of put together. I always thought of it as like one monkey is a monomer, one piece. And then as we put the monkeys together, we now have two monkeys together. I know I can't put the hands perfect, but we have a polymer. When we do a bunch of them, it's a macromolecule. In reality, guys, we would need a whole lot of monkeys, okay? And I don't have that many monkeys. Okay, so this is just what we went over, guys. All right, we've got monomers, polymers, macromolecules. We're good there. Now, how do we combine these monomers? And furthermore, how do we break them apart? You know, what we're doing here, guys, why we're making these macromolecules is to help store things in our body. So let's say one of our macromolecules is fats, which it is. It's called lipids. If we have fats in our body, we store them all in pretty much one region. Okay? Whether it's, you know, our thighs or our gut or all these different places, but we store fat. What happens here is when we have our gigantic glob of fat, we combined a bunch of monomers and put them all in the same area. So that way later on, if we need them, we know where they're at. Now let's say you're running on the treadmill or whatever and you need to burn some fat. Your body needs fat to keep you running. What you're going to do is you're going to take that fat that you stored wherever, and what you're going to do is you're going to start cutting off some of those monomers one by one by one by one, and those monomers are going to be used. So what we're going to go over here, guys, is the reactions that are going to build up that fat, make it bigger, and the reactions that break down that fat. So here are our two reactions. The top one is called a condensation reaction. This is when we are combining monomers and we get a polymer out of it. So we'd be going this way for a condensation or dehydration reaction. They're the same thing. So we are combining monomers to make a polymer. The other way, we're going from a polymer to try to split it apart and make monomers. I will show you examples of them, don't worry. Now, we're going to go over these guys, but I'm letting you know we're going to use these reactions throughout the whole chapter. So you need to know the difference between them, and you need to know what is formed in each of these reactions. So here's our condensation one. I know, it looks intimidating. Here's our hydrolysis one. Again, I get it. It looks intimidating. But let's look at one thing here. On our condensation reaction, look at your product. And I know my screen is slightly hiding it. But we have water over here. All right? Water is a product. Okay, water is a product. That is for condensation and dehydration reactions. Go to the other one, hydrolysis. Water is a reactant. if we do not have water here, guys, for a hydrolysis reaction, yeah, it's not going to split apart. We're not going to get our monomers out of it. Okay, so let me go over the difference, how I'm going to draw them, and I think it'll be a little bit easier than the book's pictures. So we're going to do a condensation, also known as a dehydration reaction up here. And down here we'll do hydrolysis. Okay. All right, so we are going to have two monomers, and we're going to combine them together on the reactant side. On the product side, we are going to get those two monomers and put them together. Okay. Now, for every bond we form, we are also going to get one water molecule out of it. All right, so that is a condensation reaction. Now, let's say we do this, and I want to combine all of these together. So they have 4 monomers. Okay, let's draw this out. So we're going to combine all 4 of these together. So I'm just doing another example here. Let's count. We would have 1, 2, 3 bonds connecting these together. So out of this, I would get 3 water molecules. Okay? Let's do one more. And then we'll go to hydrolysis. All right. This one's a little bit tricky because I have these original bonds here. So I have a polymer plus a monomer and a monomer. So let's combine our new monomers here. I have 1, there's our first, and then we got to add our second one on. Boom. How many bonds did we form? Well, there's 2, so we would get out 2 water molecules. So those are the condensation dehydration reactions, guys. We are building up. Building up. So we're making it bigger. Let's do a hydrolysis one now. I'll just do the easiest one here, kind of like we did above. If we are going to break this one apart, oops. We are going to break that apart. And how many bonds did we break? 1. Okay, we broke this bond right here. So instead of the water being in the product side, we are going to need 1 water molecule to break that. So hydrolysis is breaking down. We're making it smaller. Okay? Okay. Let's say we want to break this one completely apart into all of its monomers. We want all monomers out of this. 1, 2, 3, 4, 5, 6, 7. So we'd have 1, 2, 3, 4, 5, 6, and 7. Let's count how many bonds we broke. 1, 2, 3, 4, 5, 6 bonds. So we would have 6 water molecules we'd have to add to the reaction on the reactant side in order to break them all apart. Okay? Let's say for the last one, I'm going to do that same chain. And let's say the problem says you need 3 monomers. So I want to break 3 of them off. So I'm going to have 4 bonded together still. 1, 2, 3, 4. 1, 2, 3 individual ones. So let's see how many bonds we broke there. We want to keep 4 together. So I would have broke 1, 2, 3 bonds. Right there I broke my 3 bonds. So I would need 3 water molecules. Okay? So there is our thing right there. All right, guys, so that is it for condensation, dehydration, hydrolysis reactions. That is it for the day. Tomorrow, we will get into something called ATP. We'll do another hydrolysis, condensation, dehydration reaction with that, and then we'll start on the actual macromolecules. Have a good day, guys.